Hi everybody for being here today for this periodic seminar. Today we have the honor to welcome and host the talk by Gaëtan Miguel, who is a new PhD student at the lab. He's from Chile, and he did his Master of Science at the University of Turin in Italy, and then he went to work in research and development at the Telecom Italia lab, and he was also a project manager for a few years. Right? And lately he was assistant professor at the Faculty of Engineering at the Universidad Andrés Bello in Chile. So you will have around 30 minutes to entertain us on the subject, an information-centric network prototype for Internet of Things. He prefers that to go till the end of his talk before taking questions. So, yeah, enjoy.
So thanks, Patrick, for the introduction. Today I'm going to talk about a little extension of my Master of Science thesis work. I have worked developing a prototype of a network that works under the information-centric model. And in this presentation, I would like to show how this work could be extended in the context of Internet of Things. So, let's start with the agenda. I will explain a little of the research context, the motivation. I will define a problem statement, and I will show the approach proposed with the description of the prototype. And I'm going to finish with some conclusions about the contribution and future works. So let's start with the research context. The research context, it is related with the origin of Internet. At the beginning, Internet was revolutionary packet switching solution suitable for HTTP, FTP, email, for application that works very well under the client-server internet model. But today's internet, it's very different. The complexity has grown a lot, and we have protocols, peer-to-peer protocols, voice over IP application, content delivery networks, overlays, all of them working under the same client-server internet model. So, what's about the future of Internet? Here there are two main visions. One says that it is convenient to continue with the so-called architectural patchwork. So if we have issues, we can solve it and continue with the same internet model. Another vision is a clean slate vision. So to rethink the internet without considering the existing architecture. In this context, I have worked in Telecom Italia in the context of the Forward project, developing a prototype that works under the information-centric network model. So, what I am going to show now is how this master thesis work could be extended in the context of Internet of Things. Why Internet of Things? Because Internet of Things is one of the most probable scenarios of future Internet. So, so why to put together ICN and IoT? ICN is one of the most relevant paradigms for the future Internet. Most research confirms that. ICN integrates very complex features such as naming, name-based routing, in-network processing, and cache as part of the network architecture. but this is commonly supported in more powerful nodes. So anyway, thanks to its properties related with the content retrieval, so that is the main feature of the information-centric. Information-centric has been considered as an applicable solution in the context of IoT. So these are the motivation. However, the research in the ICN-IoT context is still considered as incipient because there are still many challenges in terms of the realization of a unified ICN and IoT proposal. Anyway, ICN and IoT have been considered as part of the next and third generation of the evolution of Internet of Things in recent articles. So that's why I'm considering to do this. So the problem statement of this work focuses on the definition of a unified solution that is valid for typical IoT nodes and is valid for an ICN node with greater capacities. And the prototype I am going to show is ICN IoT generic node that could serve as a basis for operation with heterogeneous IoT devices that works under an information-centric model. The approach was based in the network architecture of NetInf. So if a NetInf, that is one of the proposal of the architecture of information-centric network, I am considering ICN IoT nodes, this generic node, simulated in FreeBSD virtual machines through VMware. Inside of each of these nodes, there is a convergence layer implemented with NetGraph, which is a subsystem of FreeBSD, and that allows to modify the network stack, and with packet generation that simulate the IoT GET request, the IoT clients. So this picture show the approach, and here we have the FreeBSD network stack, and I'm going to show how I can put a ICN IoT layer inside the kernel. I am using to do this NetGraph. This is the subsystem as I mentioned before, which provide a wide range of NetGraph nodes of arbitrary complexity. It has nodes for interface, for socket, for Ethernet interface, and with this node, with these modules, it is possible to construct a graph, to build a graph based on the existing node, or even to create new nodes. So the result using NetGraph, it is the showing in the picture, and it is composed for 4 existing nodes, one NetGraph Ethernet interface module that it is connected with a NetGraph Ethernet filter. I will show how it works, and with 2 different kind of sockets. So there is a module that connects it with the application layer, that is a normal socket, and there is a kernel socket that allows to communicate in the inside the kernel. So it is a kernel socket, plus a new NetGraph node that I call NetGraph Convergence Layer node, that's allowed to include the feature of information-centric networking, an information-centric model, inside the generic IoT ICN node. In this node, I just implement the forwarding through flooding, so it is simple. But the idea is to include more complicated functions such as naming, name-based routing, and network caching, in-network processing, caching, that are part of the native architecture. The node it is contracted by hooks, so we have two hooks that receive the message internally, receive UDP datagrams and Ethernet frames in this case, and can send the datagrams or the message directly to the application layer. So the experiment, the simple experiment I did are related with receive and forward messages, receive and forward message in the context of ICN environment. So the receiving of different kind of layers in the same generic node allows to receive UDP datagrams and Ethernet frames. In this case, this is not a normal Ethernet frame. This is an Ethernet frame that has a different ether type. So it simulates a frame of a protocol of IoT protocol. And in this prototype, it allows to forward the processing of the message to another generic node or to external devices by a UDP datagram. It is important to notice that this kind of generic node don't interfere with the traditional network packet behavior, so they could live together with the current internet model. So how we can receive an Ethernet message and how it works. In this case, there is an Ethernet message which ether type is a different a special ether type. So when the interface receives the frame, so here in one, it will filter the frame and send it directly to the module of information-centric. So it doesn't go to the normal network stack. So here it is received the frame, and it is received, in this case, a GET request for data. It is important to explain that information-centric network model use data as the main element in the network. So when someone requests for something to the network, it doesn't request directly to the server. It just requests the data. It just requests for a content. So this is get for a content in the network. So it acts to the network. It could be in every node or just in one node, but it is not asking to a direct IP address. So that's why here this module who is in charge to control the tables. So it will depend anyway of the architecture. In this case, it is based on native ICN architecture. So anyway, the frame will arrive to the NetGraph convergence layer node, and in this case, the table will forward the message to another node. So in this case, the message will be re-encapsulated in a normal UDP message. When arrive this normal UDP message to other nodes, so it's the same generic IoT node, it pass through the network stack. So we receive just a GET request and process again inside another generic node. And if, assuming that this get request, it is inside that node, so the contours are inside this node, it could pass directly to a convergence layer in the application layer if there is a service, or it could be processed inside the node. So this is the result of the prototype that I consider that the as a main conclusion, that this node serves as a basis to work with heterogeneous IoT devices. So devices that work with UDP message, or the devices that work with other layer message, but under an information-centric model. The contribution is to design a generic node that was an extension of the native architecture, and the contribution was also to propose a convenient node that separate or combine the functionalities of both paradigms in the same node, implementing a simple forwarding of protocols of different layers. Anyway, it is important to notice that this future, as a future world, it's important to update this node, because there are many others ICN architectures that have been more developed. So NDN is now one of the most used architectures. So it will be convenient to update this idea to more used architecture of ICN. Evaluate also other kernel-based approaches, implements features such as in-network caching, and evaluate the performance, and experiment with real IoT case studies using common wireless communication protocols and IoT platform. That's all.
Thank you.
Thank you.
So now we have room for plenty of questions. So yes.
Yeah.
First one.
Can you please provide any kind of intuition behind the assumption about computational capabilities of the device which is a part of ICN? I mean, how capable it can be? Should we think about it that it can be integrated in my T-shirt, or it's something more for the jacket, or it's something more for the backpack? I mean, what is the minimal requirement of the computational abilities that would make ICN work?
Yeah. There are a paper that tried to explain that it is possible. So trying to separate which are the minimum requirement. It is not my paper, but it is a recent paper, and it said it will depend. So this paper showed that it will depend on the capability of the node. So if the node can implement it, it will implement it. The minimum for the model, so the ICN idea, the ICN paradigm, is the naming. So it is important to use the same naming, but the sensor, the IoT sensor, just can ask for information. It is not needed. But if it's a node that with greater capabilities, it could implement other features inside. It is considered that, or it is expected by the paradigm that all nodes could cache contents. I don't know. Yeah.
I see you focus on like a heterogeneous network scenario. Do you consider like different function nodes? Like some nodes are camera nodes, some nodes are like messaging nodes. Or, yeah. So how they communicate with each other in this ICN structure?
So this is just a prototype or just a structure. So the idea is that inside a generic node you could have different ways to arrive. So we can have different interface,
Yeah,
and all of them can be processed in a same layer.
yeah, but maybe different data types have like different QoS requirements. For
Yeah,
example.
yeah. I understand. So it is needed that the get, so the query, follow the same naming structure.
So you handle them in that NGCL model.
No, I didn't handle. This was just so this was a paper of a conference of 2 years ago, when no others prototypes were like working on this idea. I just tried to show that it's possible and it served as a basis. So that's why in the conclusion I understand the recent state of the art to update this generic node to the most common architecture.
Okay. So for example, if I want to add this QoS control function, which model should I work on in your node?
Sorry.
For example, if I want to add some QoS control function, which model in your generic node should I work on? That's the NGCL or where?
It could be here or it could be here.
Oh,
If the ICN consider or allows to modify, such as this prototype in the kernel, you put here. You can put here, but it is a rigid structure. It must to be anyway at the application layer.
I have one if it's.
I would put one question. The size of the buffers at each node is not infinite, right? It's not unbounded. So how do you manage the routing protocol for the message transmission from one node to another? Is it like fixed beforehand, or it's something that can be dynamic in your?
In this prototype or in the Akinet? Now in this prototype there is no routing capabilities. You know, it's like just forwarding by flooding. The paradigm consider a name-based routing that is part of the node. Okay, so this architecture could be modified because they are there is interest to extend it to the internal things. So it could be we have to use the routing. Now we have to use the routing name-based mechanism that exists in the architecture.
Because I'm wondering how you can configure such a settings in the sense like how easy is it to add a new node to complete the picture or to remove one node? How do you make the other nodes aware of this?
In this protocol, it is not possible.
Okay.
So there is no the node didn't know it is how do you call static information, not dynamic information. So it is just simulated. You put, but the most recent architecture they have name-based routing as normal routing protocols. So it is already solved.
Okay.
It could work like the normal protocol we know, OSPF, RIP, I don't know.
Few more questions.
If it's
Yeah, yeah, sure.
The basic one, in terms of technologies, because since IoT is kind of a big buzzword, many of the big software development players are, are saying that their products are available for, can be used for IoT, like Oracle, whatever. Do you have any, could you provide any kind of forecast? What kind of technologies do you expect to be useful, particularly in the context of ICN? Or
Yes. The last years, Cisco, both the most developed prototype that is called NDN, Content-Centric Networking platform, with the idea to use it in content routers that already exist, and with the idea to extend it, their research in the context of IoT.
So does Huawei have a similar platform?
Similar has content routers that are, but they are not working all of in the information-centric paradigm. So there is a router with cache, there is a router with some capability, but they work like in internet. But anyway, it is something that we need to go inside to more understanding of it.
We still have room for questions.
I don't have any particular question to this, but I just wanna. So basically, in networking, you have a concept of flooding. Are you aware of that? What is a flooding?
This one? Yes, to send to all the nodes. Yes.
But not exactly. So in sensor networks, it's not about flooding is a way of determining what's also the best path to get the information faster. I'm just thinking, like, how can you use smartly? Like, is it possible to use this centralized way of nodes and have like where the information is going and how the best path to flood to the information is changing? Those kind of things. Have you ever like thought about those kind of aspects in
Yes. So the thing that I'm showing something that maybe is not the best solution, because it was my solution and it's,
yeah.
But yes, the
No,
other platform consider that,
yeah.
and the flooding is one of the forwarding mechanisms that are inside the normal ICN nodes.
Yeah.
But these ICN nodes are not really ICN-IoT nodes. What I am suggesting here is with that platform that are more developed and they have all this feature, we can do, as in this case, to adapt the node to create a generic node. So we can have ICN and IoT nodes. So as part of the same network, as part of the same internet environment, without the need of IP.
So did you do any kind of implementation? Did you do any kind of implementation for this? Like, what was the work done? Like, what was the prototype done for this? Like programming and.
In this one?
Yeah.
Yes, I did this. I programmed this.
No, but how did you use? I'm asking. Like, what was the exact experiment? Like, what was?
Yeah. It was not. They were not performance experiment.
No.
In this, as I said at the beginning, so this is an extension of my Master of Science thesis. When there is no prototype, there is nothing working on. There is no other prototype. So my mission was just to make it possible. And yes.
But did you have any use case to do that? Like, do you have any ideas? Like, what would be your best use case to show this?
Yes, there are, but I don't have now in my mind. But yes, there are like for example, if a sensor asks for temperature and this temperature has some time request, and there is another node that has that information, the network could provide what you are asking without to go to the server that has the temperature or the time or similar requirements.
Thank you.
A few more questions. I mean, we have to put questions because the food is not ready.
As far as understood, the simulator was implemented in FreeBSD.
Yes, this one, yes.
It was the personal preference, or FreeBSD was providing you some functionalities which were like for purchase and were not available in other.
It was just because because it has netgraph which is easy to program and to connect existing model to create a graph. So that's why.
But it's like it's some kind of like declarative language, or
unfortunately it was not a performance decision. It was a decision related with how we can explain that we can do it.
Mm-hmm.
And this was the easy way.
Okay. The proof of concept.
Yes.
One last question then. And how do you consider, how do you envision considering the timing aspect? So because you can have some time delay between two IoT clients, right? You can have some delay constraints between two nodes. How do you envision to take this kind of constraint into account with this kind of settings?
I think it is a complex question because it will depend on the case study. So it will depend of.
I mean, as you said a few minutes that,
here,
for instance, if a node has a temperature that is requested by another.
Yes,
node.
but it's not a time constraint.
Yeah, but it is. It has a time bound for the information to be available at that node. I mean, the time you send a request to check for the temperature in the network is also bounded. Otherwise, the value that you will collect in the end will not be correct.
Yeah. I understand. So there are like naming in the naming there are metadata. So where you define if there is I don't remember the validity. So like the time validity. So it is if this is older than 1 minute, okay, you cannot use it. So maybe the network will provide something that is not useful, but the network didn't provide time. How do you time constraint? Yes, the network will not provide the time in the time you want. So this is just it is not to design with that focus.
Okay, I think we can stop anyway here because the food is ready. So thanks again, Miguel, for this talk. And please, guys, fill the form online. We'll keep you updated for the next periodic seminar, which is something 3 weeks from now. Thanks again.
Thank you.